Hello everyone, thank you for joining us today on this webinar of SAP vulnerability scanning. Uh, I'm Andrew Morris from Turnkey Consulting. We're a risk management organization which help our customers with all aspects of their business risk, from the processes to technical implementations, including governance, risk and compliance, identity and access management, cybersecurity, and application security across the enterprise. I'm a managing consultant for Turnkey Consulting, working in the cyber and application security fields, and I've been in this industry for around 14 years, handling SAP. What we're going to do is take you through some of the typical findings that we see while observing vulnerability scannings.
Hi, I'm Mary and I'm an analyst at Turnkey Consulting, and I'm just going to take you through an introduction, explain why vulnerability scanning of the infrastructure is important, and then go through some of the most common vulnerabilities that we see. As cybersecurity threats and risks evolve, organizations must continually evaluate their environments to minimize the likelihood of disruption or compromise through new avenues of attack. In the constant strive for top quartile maturity, many organizations now consider total end-to-end security of their environments. Comprehensive vulnerability management programs constantly target to ensure that the applications and infrastructure utilized by the organization do not possess any issues which could result in degradation of performance, cause data integrity issues leading to poor decisions, or lapse in confidentiality, which could negatively impact the reputation of the organization. At Turnkey, we spent the last 15 years securing access to SAP on the application layer, introducing access controls, privileged access management, automated process controls, and risk solutions to ensure that employee access is managed and risk-free. But few organizations have looked below that application layer to secure what SAP is actually running on. In the complexity of SAP, often a combination of dozens of servers, databases, web servers, and application layers combined with the highly specialized nature of the software can lead to most organizations overlooking SAP when it comes to their vulnerability management programs. With virtually all SAP user activity performed across the application layer, it's not hard to see why direct access to the infrastructure often gets overlooked. But as applications become increasingly integrated and more users and applications have access to the infrastructure, we need to start addressing these risks. So why should we manage the infrastructure? Every piece of data that's available via the application layer is actually also available via the infrastructure. As well as data storage, the infrastructure manages how the data is configured, processed, and transmitted. In particular, we're referring to the custom code and SAP transports, where Andrew will go further into detail. The importance of data integrity in the infrastructure has been recognized and reflected by the relevant regulation and legislation that's been put into place, like GDPR, and regulations that cover more specific types of data, like the Payment Card Industry Data Security Standard. Some of these will also require audit reviews to be performed on the infrastructure, and they're always continuing to drill further into the estate. On top of all of this, criminals and malicious users are aware of the increasing focus on application layer security, and they're identifying that the infrastructure is an easier target to disrupt, with multiple areas including networks, interfaces, and the operating system and database software. Turnkey have performed numerous vulnerability assessments for our customers, and we wanted to share with you some of the common issues that organizations can face of any scale and size. Let's start with the common cyber vulnerabilities. Many organizations will currently perform vulnerability analysis on the servers and databases hosting SAP, but not the application layer itself. Specialized tools are often required in order to investigate every corner of SAP. While the specific vulnerabilities identified will be based on the version and type of SAP platform you're using, here are the most common issues that we typically observe. Firstly, 10K Blaze. 10K Blaze is a critical vulnerability first identified in 2019 that allows a malicious user inside the SAP estate to update and extract data or execute any command within SAP. This can be a challenging vulnerability to manage, as multiple changes must be made to access controls lists on the SAP gateway and message servers. To fully mitigate this risk, organizations must specify every IP address for every interface and server which is permitted to talk to SAP. Secondly, controls in non-production clients. A lot of focus has been spent on the production clients, but many organizations have historically overlooked access to the non-productive clients, such as 000 and 66. Historically, organizations have left the management of these clients to basis teams, which has led to a wide range of access and default accounts, such as SAP Star, DDIC, and SAP CPIC being left unmanaged. All of these provide opportunities for attackers to gain a foothold on your SAP estate, as controls such as access control and single sign-on are often not active. Development to production. Many organizations focus their attention on the production SAP systems, but when it comes to vulnerability management, all SAP systems need to be considered. With the right conditions, the user with access to development or UAT systems can make changes directly in production, either directly by exploiting a vulnerability or via transports or custom code. Restricted access needs to be introduced in all SAP systems and all clients. Excessive services. This vulnerability will be of no surprise to organizations already performing vulnerability management, but we still see many organizations with services, both on the servers and on SAP, that are not required yet still running. The rule is clear. If a service isn't needed, then it must be disabled. No logging. For many years, logging the activities on the database or operating system was considered expensive. Unless it was done correctly, organizations would end up with the logs of the SAP application being duplicated as SAP made changes to the database, resulting in the inability to determine what people were doing directly on the database. Even if they were using their own ID and not using the SAP ID. In SAP itself, many organizations still don't have logging turned on to capture usage of critical transactions or changes to key tables. Not patched. SAP, like any other application, needs to be kept up to date to manage vulnerabilities. This can be a challenging task in SAP with the amount of testing required, but it is a critical activity. Ensure that patches are applied and configured in line with the patch notes. Insecure communications. Ignoring interfaces and integrations, SAP itself sends a lot of internal communications, especially if the SAP system is a dual stack system. These communications can be intercepted, read, and manipulated unless protected by transport layer security. Review your parameters to ensure that all communications are sufficiently protected. Dormant accounts. Servers, databases, and non-productive clients of SAP don't often see the same level of attention with regards to processes. Mover and leaver processes are rarely executed, and as a result, there are often dozens of accounts which belong to individuals who have left the organization a long time ago. Often, this is combined with the accounts using a non-standard naming convention, making it really hard to identify the owner and have excessive accounts such as SAP all or full access to root. Flat networks. Many organizations still have SAP accessible from anywhere on the network. This dramatically increases the attack surface that a malicious user can exploit. By placing a SAP behind a firewall or similar network protection, you can minimize the chances of a vulnerability being exploited. Even non-production systems should be protected in such a manner, as there are typically a number of ways of jumping from development to production given the conditions. Treating these vulnerabilities is similar to treating the vulnerabilities of any application. Apply patches where available, disable services which are no longer required, and lock down user access everywhere that's possible. The biggest challenge is to ensure that there's no impact on interfaces that connect to SAP. Often, if they've been connected for a while, they might not support end-to-end encryption or stronger passwords. That will need to be included as part of your assessment. I'm going to pass over to Andrew now to talk about the SAP custom code and SAP transports.
Thank you, Mary. So as Mary covered a moment ago, a lot of these changes and vulnerabilities are introduced through configuration of an SAP environment. And SAP custom code and transports are two of the main ways that configuration changes are made to an SAP system. So when looking at an overall secure SAP system, you need to consider the avenues by which changes can be made to SAP. And it's an area that a lot of organizations overlook. Now with custom code, it's incredibly rare for a customer not to customize SAP. A typical ECC system has around 1 million lines of custom code in its production system, and these can be anything from new reports for legislative or regulatory reasons. They can be new transactions to speed up business processes, or just changing the default SAP screens to customize them to look more suitable for the organization in question. Typically, with custom code, we see around 8.1 issues per 1,000 lines of code. And so these issues are areas like the other vulnerabilities you saw before, which can introduce availability, integrity, or confidentiality issues within SAP. So you can imagine that an SAP system that has been around for decades will contain a significant amount of vulnerabilities, especially if code scanning has never ever been performed before. Typically, the vulnerabilities that we find within custom code can be broken down into a number of areas. Things like security. These will be ones that programs which connect to other remote systems or contain vulnerabilities which could be exploited to inject data. So after locking down all of the different avenues via patches and parameters, if a custom code is making its own insecure connection to another server, you've just introduced a brand new vulnerability into your SAP system. Also, security concerns are things like custom code which does not perform proper authority check statements. So it's not correctly checking if a user is authorized to access a specific piece of data. Custom code can introduce some compliance issues. So code which can make changes to custom state, such as direct modifications to the database, or even contains hard-coded business data, such as bank accounts. Information which should be sufficiently protected, but is available for anybody to see. Performance is probably the most common one that most organizations have already encountered. How many times have tickets been raised in your ticketing system due to poor performing SAP because it's going slow due to a custom piece of code? The vast majority of changes on an SAP system are tweaking custom code to stop any performance issues. And if you actually check custom code before it reaches production with a proper code scanning tool, you can minimize that chance from even occurring in production. Maintainability is code which is often duplicated, poorly structured, has incomplete logic flows, and contains hard-coded values such as usernames and passwords. We see this a lot with interfaces or third-party code where it's expecting a certain username and password when it's talking over an RFC. That's not easy to maintain, it's very easy to break, and it's very hard to locate. Other poorly structured code just means it's not correctly, it's not formatted in a nice way, it's not using functions to break down code, and to update it in one area means you have to update it in 7 or 8 different areas. Robust code, or robustless code, is code which contains poor error handling, logic flows, or can modify global data. Typically, we see this as a code checking to see if something is executed successfully, and that could be an authority check statement. However, even if it fails, the code carries on executing. And with data loss prevention, this is code that exposes large amounts of data or even its own program as part of its execution or failure. This is the secure fail, secure safe principle, where if a program is saying you are not authorized to view a specific piece of data, and then it fails by displaying the entire program code or even all of the data it tried to access. One interesting challenge when dealing with custom code is finding issues that have existed for well over a decade. It can be hard to find an owner who's responsible for fixing this code. The third party who developed it might have long gone. And unless organizations spend a large time looking at custom code as it is created, all of that work securing SAP at the application layer is all done in vain. As a single piece of code or a single transport, as we'll see in a minute, can quickly undo all your hard work and introduce vulnerabilities into your application through sloppy programming. Now, SAP transports are the main way of getting changes through into production. The vast majority of all SAP changes will be made via SAP transports if you had your production system locked down. But transports themselves contain a number of risks. The vast majority of organizations will only be checking transports in terms of, is this the number we are expecting? This change should have 5. We have 5 here. They have been performed by a competent developer. Therefore, they're free to move through the landscape for further testing. But they can actually introduce a large number of issues into your landscape. Issues like security, which include the execution of programs upon import. So, for example, it allows a user to bypass the authorization restrictions you have in place in production by executing any program they want the moment a transport is released along production. Transports can also modify security roles, which can grant additional access that the security team might not have permitted. If you're not actively checking for these things, it can be a while before you realize what has changed. Also, an inadvertent change can overwrite many different child roles or derived roles in your application, where you suddenly start seeing a vast number of differences between users, and it only becomes apparent once you compare derived roles to one another and you notice there is a massive difference caused by a transport because they've gone in out of sequence. Compliance issues can be introduced via transports as well, as SAP transports can disable table logging or modifying authorizations required to execute a certain transaction. Maintainability issues are introduced when SAP standard tables are updated without any validation, or overwriting configuration changes, or making changes to the database structure. How many times as an organization have you encountered an issue in production that happens immediately after a set of transports have gone in, and it's due to a transport overwriting a key set of table configurations? We've seen it ourselves many different times. And of course, if a transport is performing a mass upload of data or a mass introduction of data, they don't always perform the appropriate validation to make sure that that data already exists or hasn't been updated since that transport was created. And you can very easily create data integrity issues if you're not properly validating and sanitizing that data before it is updated. And of course, concerns are often introduced if SAP programs, the standard code is overwritten within production. All these issues are compounded by emergency transports, which often receive less testing than standard changes. And of course, transports being introduced or imported into a production system or any system out of sequence is an old enemy of anybody who's worked with SAP for a long amount of time. One thing that surprises a lot of people when we do these vulnerability assessments is the number of development environments they have in their landscape. Most organizations only think of one development system, maybe 2, depending on the setup, one UAT environment, a pre-production or formal system, and then finally changes go into their production system. But when you look at the original source of a lot of transports, organizations can have 10 or more systems where transports can come from. If you think that your auditors will give you code to run in production, you will have third parties developing different pieces of software which you import and promote, and then other third-party software which you might buy, additional modules, add-ins, and everything else, all of which will have originated from a different source system than your core development environment. If we are only checking that the number of transports is valid and the sequence is right, we are missing so many different avenues where changes can hamper your SAP system and they can go unnoticed. It's not all doom and gloom though. We can take steps to address these, and we've seen many customers successfully do so. The first one is to treat SAP like any other application in your vulnerability management program. Don't treat it like a special case where, because of its mysterious and complex connections, get scanning the databases and servers now and use proper tooling to start scanning SAP to look at the particular specific vulnerabilities unique to it. For custom code and transports and even managing most of the SAP, you need to consider tooling. There's a number of tools available which can perform ad hoc scanning or consistent, even better, persistent scans across your environment. Managed services are also available to help you manage these vulnerabilities, to help you alert you if any issues have cropped up, or if any changes have been made to introduce any vulnerabilities. Make sure you assess all parts of your infrastructure: servers, databases, web servers and web content, application servers, interfaces, integrations, and everything else that comes in and out of SAP. You have to explicitly control what can communicate to your SAP environment and what can make changes to your SAP environment. As Mary covered earlier, with vulnerabilities such as 10K Blaze, the only true way of remediating that vulnerability is to explicitly whitelist what can talk to your SAP environment. You have to input specific IP addresses of interfaces, of other SAP servers, and anything else which can talk to it to stop any unintended consequences. That can be challenging. It can be hard to identify that, especially with a highly complex environment, but it needs to be done if you want to fully remediate these risks. Look at all of your SAP systems from development through to production. For many years, we used to say that you apply appropriate controls based on the level of risk of that environment. And that is still true. But for most organizations, that meant that you only applied all your controls to production. On the application layer, that was formal roles, emergency access management and firefighter and segregation of duty checks. But with all the vulnerabilities that are currently being exploited at organizations, you now need to consider development and UAT too. With changes being made and vulnerabilities being introduced through transports and vulnerabilities, it is critical that access is appropriately controlled in development, and also non-production clients such as 000 and 066 are appropriately locked down. We can no longer rely on a third party to manage them as we turn a blind eye to them. We need to bring them into the scope of our controls and processes and make sure that access is appropriately assigned. When you're reviewing changes, don't just review them from a functional perspective, make sure you review them from a security perspective. Are tables being updated? Are appropriate authority checks being embedded in programs? Are those authority checks inserted correctly into programs? It's very easy for the business just to test and make sure that a program runs and returns the expected output, but we need to make sure that these changes do not introduce any vulnerabilities into our system or could compromise the integrity, availability, or confidentiality. Make sure you perform consistent scanning, again through tooling or a managed service. A lot of these vulnerabilities are stopped by having proper configuration in place, but that configuration can easily be changed by a rogue transport or by moving SAP to a different server or connecting a new service. I've seen it myself a number of times where you think you have something locked down, but a support pack is enabled. And to enable those support packs, they had to make some key changes, forgot to change it back afterwards, and that has reintroduced a vulnerability to your system. Only through consistent scanning and even potentially defending and blocking certain changes will you ensure that you remain vulnerability free. And like anything else, you need to prioritize your remediation, taking any business disruption into account. The first time you run vulnerability scans against SAP or custom code or your transports, you will likely find hundreds, if not thousands, of different vulnerabilities. And it can be overwhelming to look at in terms of where do you start. Like with everything else, always start with the critical or high vulnerabilities, remediate the ones which have a very low complexity or low impact to fix, things like locking down user accounts, disabling IDs. But you need to take into account as well the ones that will cause business disruption. Communications between SAP need to be secure, but by disabling those interfaces or making them secure, you could impact interfaces which rely on more insecure communications, interfaces that haven't been updated in many years and cannot be updated in many years, that would require significant rework. At the end of the day, everything is a risk-based exercise, and you need to take into account the decision of the cost of the impact of fixing a vulnerability versus a vulnerability being exploited. If you have appropriate mitigating controls in place, such as a flat network and strict access control lists on your gateway, and nothing else can access it, then you might get away with having an open and insecure communication between your Java stack and your ABAP stack, if it means you can avoid reworking 4 different interfaces which are no longer maintained by any third parties. That was a whistle-stop tour through some of the vulnerabilities and the common findings we see. Of course, every system is different based on the modules that are installed and how it has been maintained and grown organically over the last decade or so of its lifetime. If you'd like more information from us, please feel free to reach out to us via the email addresses on the screen there. We'll also take a look at turnkeyconsulting.com, where we have many more articles and resources to help you. And you can also ask us for any additional help and questions that you might have. Thank you for joining us today.